Hey everyone, welcome to your last new learning of Unit 4, Topic 2, Exponential Functions. Last stuff to learn. So let's start by doing a little bit of a recap about exponential functions. What do they look like? So an exponential equation looks like f of x equals a times b to the power of x. And the a is represented by the y-intercept. And the b is my common ratio. So as we go forward into today's video, our goal is going to be to write the equation, write the function. So you're always going to be looking for these two things. If you can find the y-intercept and if you can find the common ratio, you're just going to put those numbers right in for a and b to your equation. So let's get started. So the first question, which of these tables represents an exponential function? So this is stuff that we've done before. Shouldn't be too hard to check which one is exponential. The thing that we're looking for is the change. How am I changing to go from 15 to 12? Well, I am subtracting 3 to get there. What about from 12 to 9? I'm subtracting 3, subtracting 3, subtracting 3 to go from 6 to 3 as well. So, with the change being a minus, does that mean it's exponential? No, it's not exponential. So this one is not exponential. Let's check the other one. What's my change to go from 2 to 8? Well, if I think 2 plus 6 is 8, okay, that's an idea. But then again, am I still adding 6 to go from 8 to 32? No, I don't. So I know that my change isn't plus 6. So I'm going to erase that. And so let's think of a different way I can go from 2 to 8. Well, the other way to go from 2 to 8 is multiplying by 4. Does this change hold with the rest of the table? 8 times 4 is 32. 32 times 4, yep, 128. Times 4. So this, it looks like the change in the second table is timesing by 4. And I know that in an exponential function, my change is multiply. So this one is the exponential function. So the next thing I want to do after I figure out that this table is exponential is I want to practice writing the table, or writing the function, I should say. So what I need to remember is from that first slide, what does an exponential function look like? Well, it looks like f of x equals a times b to the power of x, where a is the y-intercept, b is the common ratio. So if I can find those two pieces of information, I can write my equation. So first of all, let's try and figure out what is the y-intercept. Well, I know that my y-intercept is shown on my table, and it's the value that's next to, it's a y value that goes with x equals 0. So if I can find x equals 0 on my table, the y-intercept is the y value that goes along with this. So I know that I know that my value of a is going to be 2 because that's the y-intercept. The other part that I need to know is this b value, and b stands for our common ratio. Well, what's my ratio? What's my change? Well, we found that already as we were trying to figure out if it was exponential or if it wasn't exponential. So that part's already done. My change is timesing by 4. So that 4 is going to go in here for b. So the rest that I have to do is just kind of clean it up a little bit. Make sure I get my variable x as the power of 4. And then f of x equals 2 times 4 to the power of x. That's it. There is my final equation for this table. Okay, now we're going to go into more of the word problem aspect of creating the equation for an exponential function. I like these because this is more like real life connections with situations that are really happening and that you can connect to. So, if I read through this, the Ebola virus is no longer a massive concern. When it was at its most severe, there were 40 rumored cases in the United States. The number of cases decreased by half each week. So that's something that I'm kind of familiar with and I know about. So my first task, it says to write the exponential function that's going to represent this Ebola situation. So again, remember what I need to know. I need to know my y-intercept, and I need to know my change. Well, my y-intercept, another way to say that is to say, what is my starting value? Well, how many cases did we start with of Ebola? We started with 40 rumored cases of Ebola, so that's going to be my y-intercept. That's going to be my value of A, my starting value. So that number is going to be 40. And how am I changing? What is my common ratio? How am I changing each time? Well, if I look through my words, okay, so we've used 40 already. That's good. The number of cases decreased. So I know I'm getting smaller. How am I getting smaller, though? I am being cut in half each week. Well, how do I represent half with numbers? That just looks like this. 1/2. And then, so 1/2 is my change. And then again, we have to just kind of clean up the equation a little bit, make sure we have the power of x in there, and make sure we have this f of x. And that's it. Here's my equation. F of x equals 40 times 1/2 to the power of x. So the second half of my question, so this is part A. Part B is asking me to evaluate how many cases are there going to be after 4 weeks. Okay, so there's a couple ways I can do this. I think we should just go right to our equation. After 4 weeks, well, that means I'm going to plug in a 4 for this value of x. So everything else can stay the same. 40 times 1/2 to the power of 4. This is me just evaluating this function that I just created. So if I go to my calculator and I type it in, remembering order of operations, remembering that my exponent has to go first, I'm going to type in this part first. 1/2 to the power of 4 using parentheses, and 1/2 to the power of 4 is 0.0625, and then immediately sticking in my calculator, I can just take that number times by 40, and my answer is 2.5. Well, 2.5 what? So I have 2.5 cases of Ebola after 4 weeks. So this is us evaluating in this real life situation. After 4 weeks, only 2.5 cases of Ebola remain. Let's try this idea again, but I want you guys to do a little bit of work within this one too. So same type of idea, word problem. The outbreak of the measles is concerning to many parents. As of right now, there is only 1 suspected case of the measles in Iowa. The number of cases, though, is tripling each week. So, first of all, let's write the exponential function that's going to represent the situation. So as I'm going through, remember the first thing I need to figure out is, what is my y-intercept? Well, you guys, you try it. What is the y-intercept? What is the starting value in this particular situation? So the starting value is 1. I'm starting with only 1 case of Ebola in Iowa. So the number 1 is going to go right there. Now I need to figure out the common ratio. What is my change? How is the number of cases of measles changing each week? So you guys try this for me. How many is it going to change each week? So all that was part A. Why don't you guys try part B? How many cases will there be after 10 weeks? Try it on your own. So to figure out how many cases there will be, I have to evaluate. I'm going to look at for 10 weeks, going back to my function that we just created, and plugging in a 10 in for x. So I will be typing into my calculator 1 times 3 to the power of 10. So again, keeping in mind that I need to try my exponents first for my order of operations. 3 to the power of 10 is 59,049. And then make sure we times by 1. So if I times by 1 on my calculator, I get that same number. So the total number of measles cases in Iowa after 10 weeks is going to be 59,049 cases of Ebola. Try this one on your own. I will read the question to you, and then we're going to ask a few questions. Your Algebra 1 class is having a trivia crack tournament. The tournament will begin with 30 students, and half will be eliminated each round. Okay, last question here. This one's going to be more of a comparison between two different teachers. Mrs. Ramirez and Miss Brackemeyer are in a pencil collecting competition. At the beginning of the week, Mrs. Ramirez has 12 pencils and finds 2 on her floor each day. Miss Brackemeyer only starts with 1 pencil, but her amount of pencils doubles every day. First question is to write an equation for the total amount of pencils in Mrs. Ramirez's room. So we're going to be going back to our basics. We're going to be going back to f of x equals a times b to the power of x. What is the starting value for Mrs. Ramirez? I'm going to start with a total number of 12 pencils. That's my starting value. And how is that going to change every day? Well, it says here, I find 2 on her floor each day. Well, wait a second. Let me go back. Is this type of question an exponential question? Am I multiplying my starting value every week? No. So this is not actually an exponential equation. I've got to be looking at the linear situation. I am adding 2 pencils to the total every day. So that is going to be my my linear equation, which looks like this. F of x equals your change times x plus your starting value. So again, I still need to be finding my starting value. It's just going to go in a different spot. My starting value this time is going to be 12, like we said, so the plus 12 is going to go at the end. And the change, which we said was a plus 2, so we're going to have a 2 here for my delta. So Mrs. Ramirez's equation is linear. F of x equals 2x plus 12. What about Miss Brackemeyer? What's happening with Miss Brackemeyer? Let me go back and read hers. Miss Brackemeyer starts with only 1 pencil, but her amount of pencils doubles every day. So doubling, that's telling me my change is multiplying. Multiplying, that means exponential. So I'm going to go back to this exponential equation. Still looking for my y-intercept. Still look for my change, but it's just going to look a little bit different in the equation. What is Miss Brackemeyer's starting value? Miss Brackemeyer only starts with 1 pencil. So 1 is going to be here for my starting value. And how much is it changing every day? Well, it says that her amount of pencils doubles every day. Doubles means multiply by 2. So we're going to have the change for B be a 2. It's being multiplied by 2 each day. Clean it up, make sure that power of x is on there, and there's Miss Brackemeyer's equation. F of x equals 1 times 2 to the power of x. Part C is asking which teacher will have the most pencils after 1 school week, so 5 days, Monday through Friday. How many will Miss Ramirez have? Miss Ramirez, so if I go to my x and plug in a 5, I'm looking for 5 days. 2 times 5 plus 12. 2 times 5 is 10. 10 plus 12 equals 22 pencils. I'd be so happy if I had 22 pencils in my classroom. What about Miss Brackemeyer? If we plug in a 5 into her equation, I have 1 times 2 to the power of 5. So if I go to my calculator, 2 to the power of 5 is 32 pencils. So Miss Brackemeyer will have 32 pencils after that 1 school week. So whose is better? Miss Brackemeyer. She's going to have more pencils, so she's going to win the competition. This is part C. Part D says, if the pattern continues, who will eventually have the most? Well, Miss Brackemeyer is doubling every time, so her change is getting bigger and bigger each time. So Miss Brackemeyer is going to have the most pencils in the long run. Thank you for watching, and good job on topic 2. You guys have done a great job. Keep up the hard work.